You're listening to Strange by Nature, your guide to the strange, weird, unbelievable, and improbable wonders of the natural world.
Hello, everyone. Thanks for being here today. I am Kirk Mona, and I am joined today by Rachel Ginza and Victoria Thompson. We are all professional naturalists who together have scoured the world for weird and wonderful wonders just to please your mammalian brain's desire for novelty. Isn't that nice? Let's do this.
Hello, everyone. I'm very excited. I get to start us off this week.
Hey.
And I'm very excited because we actually have my friend
Wait a minute.
Alicia. They are joining us this week. They are
I was going to say, that didn't sound like Victoria.
It wasn't Victoria. That's my friend Alicia. They're a naturalist about town. Go ahead and say hello.
Hi. Excited to be here.
I got to know Alicia through one of our mutual naturalist gigs down in the cities, and they're just really fun, and they had their own podcast for a while, so I thought, hey, want to come join us for a little bit? And they said yes, so I'm very excited.
Awesome. Welcome.
Yeah. Okay.
Thanks.
So I'm getting us started this week. And, one day, I'll do a nice topic again. Maybe something that's strange and nice and maybe not horrifying. But today is not that day.
That would be unexpected, though. Okay.
Exactly.
Great. So we have something that is normal and horrifying? Or is it also strange and horrifying?
It's strange and horrifying.
Oh, goody.
Wonderful.
Excellent. And normally, to settle us in, I'd maybe tell us a story or say, hey, we're going on a walk or something. But when I stumbled upon this, my first thought was quite literally, oh no.
Oh, no. oh, no.
Oh.
So,
That makes me think, oh, no.
Don't go there.
excellent. Well, now this is my topic. So as naturalists, we often spend time in the woods, poking at dead things with sticks and turning over logs.
With sticks. Yep.
Oh, absolutely. It's my favorite thing. I don't know about you two, but I see centipedes all the time, especially if I'm turning over logs in the spring and fall and summer. So most of the seasons.
Oh, yeah.
So you want to learn
yep.
about one from my nightmares? Because it's certainly going to be there now.
Sure.
Is it going to be worse than the one from
Absolutely. Let's do it.
Uzumaki? We'll find out, I guess.
Maybe. Entirely possible.
Oh, good.
So the Amazonian giant centipede is found natively in, obviously, northern South America in the Amazon rainforest. Like most centipedes, it can be found in leaf litter or under rocks, but it'll actively hunt above ground at night. Now, most people, when they see a centipede, they immediately go, bug, insect. It's not. It's an arthropod. They have their own class and everything. They're not part of insects at all. The Amazon giant centipede is long, skinny, with anywhere from 21 to 27 segments of its body. Reddish brown with long banana, yellow jointed legs.
Okay.
That and antennae that it uses to hunt. This centipede is the largest in the world. And
That was a big sigh you just took there.
it has been found to be about a foot long.
Oh
or
no.
30 centimeters.
Lovely.
I hate it so much.
I mean, that's shorter than I was worried you were going to say.
Yeah.
Okay, that's fair, but for a centipede that for the most part, when you see one is maybe 2 inches long, to find one that is
right. Is it because you're picturing it crawling up your neck right now and while you're sleeping, it's legs are across your face?
Yes,
Is that
that is it?
That's
Yeah.
okay. That's what it is.
Yeah.
Okay, cool.
That's it.
Understandable. Understandable. Carry on.
Great. So it uses its antenna to feel vibrations. Its eyesight is horrible. So it, like a lot of other centipedes, it's a carnivorous centipede, and it hunts anything that it can overpower. So including insects, spiders, even tarantulas, scorpions, small lizards like a green iguana. It's been known to eat frogs and snakes that are up to about 10 inches long, and sparrow-sized birds.
Wow. Oh my. That was unexpected. Okay.
So large. The centipedes, and this is really what caught my attention. So the centipedes are even known to climb up the side of caves, like the walls of caves, to the top of the ceiling.
Caves?
Oh no.
Oh no.
Oh no.
Uh-huh. To the
don't like
top
where this
of
is
the
going.
ceiling.
Go on.
Where they will hang, holding on by even just a few feet.
What?
Few legs.
Oh.
They will dangle.
And dangle? Do they dangle?
God.
They are dangling.
Oh, dangling centipede.
Dangling
no.
centipede.
No, Rachel,
wait.
Why?
They wait. And bats fly out to catch and eat bats.
Oh my God.
Wait, so they catch the bats that are flying by?
Uh-huh.
Just in their
I
I would
arms.
think the bats
That's
would like
nuts.
see them with their
You would think.
or use their echolocation and see. Wow.
Uh-huh. So
Maybe
they're
they sort
able
of
to
can
catch them.
stretch
They
out or
just keep
something. That is
Well,
wild.
the bats probably aren't
Yeah, they
expecting the
just-
stalactite to move.
I
Well,
wouldn't.
that's true. If they can move, side to
Yeah.
side. Oh my
Mhm.
gosh, I don't. I suppose you know what though.
Ugh.
What I'm picturing is like a big, huge cave, and they
Mhm.
maybe hanging out in areas that are much more narrow openings where their body is filling
Yeah.
up a larger portion of it. I'm picturing a cave that I'm walking in, and they're like
Mhm.
dropping down my shirt. Oh god!
Ugh.
But it's probably a different situation than that.
I mean, probably, but I wouldn't put it past them. I think like bigger caves as well, not just these smaller ones that they can fill on their own. I think that they can also just fill the space, but they can. I think they're also just using on their own. You know,
Huh? Yeah, sure.
awful.
Wild.
So and if it,
That's really terrible.
isn't it? Isn't it?
Thank you for sharing such a horrible thing.
Oh,
I mean, it's amazing and wonderful and beautiful and part of the strangeness of
Right.
nature, and I love it.
right.
But it's also like
Isn't it
I
awful?
could go my life
And,
without seeing one of those in person.
Yep.
You know what? If it wasn't bad enough, they're also highly venomous.
Oh, there's more.
Oh,
Yeah.
good.
Oh,
Excellent.
good,
Yeah.
good, wonderful, Rachel. Thank you.
Anytime their front two legs actually act as like claws, so they are not claws, but like they can use them to inject venom into their prey. So they're highly venomous, which paralyzes the prey, whatever prey that they can overpower. But rarely, it can even kill humans. This venom, this neurotoxin.
Okay.
I don't
wow,
like that.
Ooh.
So the one that falls down my shirt, you're saying that's actually problematic.
It is.
Okay,
If anything, if it does.
And where is
bite
this
you-
exactly?
In northern South America. So you know where not to go.
So I'm a ways
Yeah.
away.
Yeah.
And generally speaking, for most people who are like our age and like healthy-ish, it's gonna cause like a fever. It's gonna be very painful, and there might be a rash and things like that. The person who was most recently documented as actually dying from a bite from an Amazonian giant centipede was a 4-year-old Venezuelan girl.
Oh.
Oh,
yeah,
sad.
Yeah, sad. Apparently, she went to take a drink from an open pop can, and the centipede had been in the pop can, and it bit her.
Oh God.
No.
Oh no.
No, Rachel,
Oh,
no.
Yeah, which is awful.
Oh, I don't like when there's like a wasp in my can.
Yeah, it's kind of worse.
That's just.
Yeah, and this was pretty recent. This was in
I'm uncomfortable with that now.
2014. So, yeah, it's not great. On a different note,
Okay.
on to try to end on a more
that's
positive
tough.
note rather than
What
the
an
death of a
uplifting story
child.
you've brought us.
And I warned you that it was not great. On a more uplifting note, when the mothers are fierce,
Sorry, children.
are fierce predators, or obviously they're fierce predators. They're fierce protectors of their eggs. They actually like curl up into an actual basket, and like all of their eggs underneath their body and their leg segments fold up to protect them, and they just kind of hang out there until the eggs hatch, which is kind of cute and kind of fun.
That
very
is
sweet.
cute. Terrifyingly
I had
cute.
to
Kind
end
of
it
cute.
on
Kind of nightmarish. But yeah.
Yeah, it's gonna haunt my nightmares. So
Cute in a demonic horror kind of way. But yeah. Wonderful. Thank you.
Well,
Thank you for sharing that with us, I think.
maybe. All right. Well, that's all I have for us this week. So we're going to take a break, and when we return, we're going to have a story from Alicia. I'm really excited.
And we're back. So I have something really cool to talk about this week. And it's something that I am really interested in. So I really love mushrooms, and I'm wondering how much you two have heard about lobster mushrooms.
Lobster mushrooms. I'm going to say somewhere between nothing and less than nothing.
Oh, good. I know that they taste like lobster, and they have a really like meaty texture. But that's about, and I know they're bright red. I've seen them. Unfortunately, I couldn't pick them because it was past its prime. So it was a sad looking lobster mushroom. But I've heard they're delicious.
So yeah, as the name suggests, they are similar to lobster. They have sort of a fishy-ish taste. They're very firm, like cooked lobster meat. And the best thing of all, they are bright, orangey red on the outside and then white on the inside. And
I am already properly horrified.
They are wonderful. They're known to be a choice edible mushroom. People love to pick them and forage them, and I also do too. But there's something pretty weird about them that a lot of people don't know about them, even people who forage and eat them. And that is that they're not mushrooms. They're not mushrooms at all.
Okay.
What?
So they're actually a fungus.
Plot twist.
They're a fungus, so they're still in the same the same kingdom.
So a fungus, but not a mushroom.
They're not a mushroom.
Okay.
And they actually can't make their own like structures. So like the thing that you're picking didn't used to be a lobster mushroom.
What?
Because it was actually a different type of mushroom.
What?
Awesome. Go on.
So lobster fungus is also called Hypomyces lactiflorum, and it's a parasitic fungus that takes over its host as the mushroom is forming.
Wow, that's super cool.
Yeah.
That's wild.
So it commonly parasitizes mushrooms in the Russula or brittlecap families and Lactarius or milkcap families. And it takes over them while they're still forming underground. So quick rundown on mushrooms. They're actually just the fruiting body of the fungus. So they're what appears above ground or on the surface of wood to release the spores and reproduce. Whereas most of the fungus lives in the soil or in the decaying wood or living wood as mycelium. So when these Russula and Lactarius mushrooms are forming, the Hypomyces gets in there and gets into the mushroom and takes over it. They've actually done DNA tests of lobster mushrooms, and there is almost no remaining DNA from the original host mushroom left.
Okay, that was going to be one of my questions because you mentioned before that there was several species they would essentially invade, and I'm thinking, well, wait a minute, if there's several species, the lobster mushrooms kind of taste different depending on what they're in. So I'm picturing like another mushroom, and this is almost just sort of infusing it, but you're talking about complete and utter taking over to the point that like the DNA is not even there of the original mushroom?
It is still there, but it is hugely outnumbered. And the texture and the flavor of the mushrooms is changed by the hypomyces, by the lobster mushroom or lobster fungus.
Right. Does the taste change depending on what the host mushroom is?
Yes, it does.
That was my next question too.
Yeah, so Lactarius pipeраtus is one of its common hosts in North America, and that's what you'll commonly find it growing on in Minnesota. Those are technically edible, but most people find them so like spicy level bitter that they're like not pleasant to eat.
Ooh, spicy and bitter. What a combo.
With the lobster fungus, it takes it over and it neutralizes that bitterness and makes it edible. Okay. And then similarly, there's another common host in Mexico, Rusula brevipes, which is a type of brittle cap. So it's really crumbly, which is great if you want to like break it apart really quick and make like fried up little bits of mushroom. But the lobster changes its texture in that case, and so it becomes a lot more firm and cohesive.
Oh, wow.
Huh.
That is wild.
Yeah, it's really strange. And they're really wonderful, though, because like they're super easy to identify. They have no lookalikes at all, because they're bright orange, sticking out of the ground, and they grow wherever their host mushrooms grow, so you can find them a lot of places.
They're so tasty. I've heard they're tasty. I feel like I've tasted maybe a little bit.
Yeah, they're pretty good. There's a lot of mushrooms out there that just sort of take on the taste of whatever you cook them in. And then there's like the standouts that people are really like go after, like the morels, the chanterelles that have a more distinct taste. And I feel like lobster is kind of in the middle. Like they have a bit of a taste to them, but nothing that's like really out there and gonna like taste weird to a first-time forager. And
I mean, other than lobster, which is kind of a weird thing for a mushroom to taste like.
Yeah, especially in like the middle of like the country. We're not exactly known for our lobster.
Yeah, so you could probably make a really good lobster mushroom bisque. I bet that would be delicious.
Ooh. That's what I was just gonna say. Yeah.
Or lobster rolls. They go for like $20 a pop here.
Some cheddar bay biscuits on the side.
Ooh.
So you can actually
online. We could do it.
Yeah, we could make it happen. And you can actually, if you're not feeling confident enough to get out into the woods and find lobsters, or if you're in the Northern Hemisphere right now and it's wintertime, you can actually commonly find lobster mushrooms at a lot of like co-ops nowadays, because they are such a funky little thing that people really like to eat.
Like, look at this tasty
Very cool.
meal.
I had no idea.
I certainly didn't know that they took over a mushroom or another mushroom or fungus's body.
Yeah,
wow.
That's the crazy thing. That's the thing is like someone's going to write a sci-fi novel where in like 50 years we've all been eating too many lobster mushrooms and they've just taken over our brains and then we're all lobster zombies.
See, yet another reason why, folks, I don't eat fungus. There we go. I will be safe.
You will be safe.
I said I was horrified at the beginning. There's two things I don't eat: fungus and seafood. So this is like a double no for me. But I'm glad that you enjoy it. But I will be safe from the eventual lobster people apocalypse, I think.
Then the cordyceps can get you.
Yep. Yeah, that'll be the second wave.
There's always something. Shoot. All right, well. What can I say?
That's all I got on lobster mushrooms. So we're going to take another break, and then it will be Kirk with something else.
I'm going to jump in here and just say that while we've been recording, we've actually had 2 new followers join us over on Mastodon. So hi to Frosty and hi to Open Science, who both literally followed us while we're recording. We're getting all kinds of new followers over there as people are joining the party. Speaking of party, that's the server we are on. It's mastodon.party, which is spelled mstdn.party because it's abbreviated. So if you want to follow us, check out at Strange by Nature at mstdn.party, and we'll hope to see you there.
Yeah.
Welcome back. Okay, so anyone who's been paying attention knows that this topic was coming. I basically came up with the idea to do this topic in the middle of an episode, which presumably most of you listen to. No obfuscation this week. I'm just talking about amoebas and amoeboids. So this topic came to my attention, I guess technically as a child, but more recently,
Fair.
it was a couple weeks back while researching the topic of the self-organizing slime molds that were able to recreate the efficient layout of the Tokyo subway system, which is a really cool story. So I'll insert the obligatory request that you go listen to that episode if you haven't. But while I was researching that episode, I read about how the slime mold would send out these little like pseudopod tendrils of itself, and when it found food, it would surround the food and digest it. And like a little bell went off in the deep recesses of my brain, and I was transported back to 9th grade biological science class. And in hindsight, I had a pretty cool teacher. He was a birder, like decades before I knew how amazingly cool birders were. He also had tons of like aquariums in his classroom. Very much, that were filled with every imaginable creature hiding behind live aquatic vegetation. He basically had like whole ecosystems growing in his classroom. Very cool. One side note, I also remember he had like half of a mountain goat taxidermy like mounted on the wall. That's one of the kind where you have the head and the front feet. And he used to joke that he had a bet with the teacher next door and he won, so he got the front of the goat in his classroom and the other teacher got the ass end in his classroom. Now, later I had that teacher too and discovered that was not actually true, but he was a joker. So the classroom was lined with these black acid-proof countertops, which I'm sure a lot of you are familiar with. And I have this distinct memory of like tests where the whole classroom would be full of microscopes on those countertops, and they'd be numbered, and we'd have to peer into the scopes and confidently identify what we're seeing. And number 1, Spirogyra. Number 2, Volvox. Number 3, Hydra. Number 4, Euglena. And so that was seriously our test as we were going around the classroom. And
wow.
I remember many of those things years later, so it seriously stuck with me. And one of the things I remember looking at in class was the amoeba. And they seem like such a bizarre and alien form of life. Mm-hmm. And so as an adult reading about slime molds, I decided to check out the Wikipedia page of all places about amoebas, just kind of out of sheer curiosity, because this sounded kind of like the kind of thing an amoeba would do, their behavior. Mm-hmm. And to my shock, I discovered that I've been living a lie. Now, this probably happens a lot, but it turns out that my 9th grade understanding of amoebas was wrong. Who would have thought,
really?
Right?
Really? Crazy.
I don't know that I can. Right. I don't know that I can blame my teacher. 9th grade isn't exactly like the pinnacle of education and like, paying attention to what you're learning. Mm-hmm. There's other distractions like the bully who punched me in the face in that class. But, I may not have correctly understood every nuance of the subject matter. But asking around, though, it sounds like the misunderstanding I had is a misunderstanding that a lot of people have. As it turns out, there's no such thing as an amoeba.
What?
Right. So Victoria made a joke on the show 2 weeks ago about this, that there's a famous book called No Such Thing as a Fish. Oh, yeah. This all comes from a quote from Stephen Jay Gould, where he basically points out that everything we call a fish is not necessarily actually closely related at all. And we could really break them into different groups.
That's been a debate in my workplace recently. We have a whiteboard where it's either everything is a fish or nothing is a fish. Nothing is a fish is currently winning.
Right. There really shouldn't be a monolithic group called fish. They don't actually share sort of a recent common ancestor. Mm-hmm. So there's a bit of a similar thing going on with the word amoeba. As it turns out, there is no group of animals called amoebas that we can lump them all into one group in the same way that we could say birds or mammals and such. So amoebas or amoeboids if you prefer, are simply creatures with similar styles of locomotion and digestion, that whole pseudopod thing that they send out. That's what makes something an amoeba. And I use the word creatures very carefully there because we're not necessarily talking about animals. I mean, some of them are animals and some of them aren't. It kind of depends on what you're talking about. So there's actually amoeboid creatures in every major lineage of eukaryotic life. There are amoeba animals, there are amoeba algae, there are amoeba fungi, there are amoeba protozoa. Like, then they're not necessarily really related. Okay.
Whoa.
So
okay.
truly,
Well, I mean, that makes sense, but at the same time, I know nature laughs at our categories, but this is taking it too far.
right. I mean, truly an amoeba is not one thing. And I think we all get the impression it is from teachers in school who have ordered amoeba samples for us to look at. I thought my teacher was out there dipping in the pond looking for amoebas. Turns out you can just order them, like, from a catalog. And so if you peered at amoeba in a school microscope, you were likely looking at either, and I love these names, Chaos carolinescens, I think is how it's said, or Amoeba proteus. Those are the two most common ones. And they're actually very close. Those two actually are closely related. So these are the two most common ones used in schools. And they're probably more like what is classically thought of as an amoeba. I mean, the genus of one is even amoeba.
Right.
So like this is sort of your classic amoeba. And it's maybe perhaps because it's like too complex of a topic and teachers don't want to confuse ninth graders. Or perhaps the teachers themselves don't really know the truth. Or perhaps because they do know the truth and they told us the truth and we weren't paying attention, which is absolutely possible.
Entirely
I think we all
possible.
assumed amoebas were a specific type of creature instead of a particular form of locomotion favored by many types of life. So maybe this one's on us. I'm not sure. I did mention different categories of life that have amoebas, and I'm sure people are curious, so I'm going to end with an example from each of the areas of life I mentioned earlier. So here we go. The amoebas you probably saw in school were examples of protozoans. Some people call those the true amoebas. The famous brain-eating amoeba, Naegleria fowleri, which I've talked about on the show, is actually a percolozoa, which is a completely different phylum of life from the other amoebas.
Of course.
I already mentioned the slime mold, that is an amoeboid. That would be in the phylum Mycetozoa or Mycetozoa. We also have, these are all such great names.
Yeah, you're doing great.
Thank you. Synchroma grande.
I like
It's
that
big.
name.
It's a benthic marine amoeba that is actually a type of algae. And so not only is that a different phylum, now we're talking about an entire different kingdom of life than the other ones we've mentioned, which is pretty awesome.
And it's really far
then-
down too. Like that, the pressures and everything down there.
Oh, yeah.
Crazy.
Yeah. Pretty wild. And some amoebas are actually more like cells that are part of larger systems. So marine sponges, which are animals, by the way, have amoeboid cells in them, and so do you.
What? Wait.
Oh,
Is
yeah.
this?
You
Is
have a
no?
Is it-
mitochondria?
not
Is it- is it-
no.
it
You always
white-
want to bring it back to
white
the
blood
powerhouse of the
cells?
cell, don't you? Yeah, leukocytes, white blood cells. The things that fight disease in your body, they are technically amoeboids. Again, remember, not because they're related to those things you studied in school, but because of their form of locomotion. They are these blobby things that, surround and, in this case, destroy things invading your body. So amoeboid locomotion is likely one of the first forms of locomotion on Earth. So it probably shouldn't be surprising that we have lots of things, still around that have diversified and used that form of locomotion. So there you have it. Amoebas, not just one thing.
Okay, but then so it's the type of motion for the thing
Yeah.
for many different kinds of things across all life. Why do we still
Yep.
call them amoebas if they're all different
Well,
things?
what it probably comes down to, So there is something like probably what you studied in school, that thing you saw, which is a protozoan, we call an amoeba. In fact, that genus of, amoeba, that amoeba genus, which we've sort of split things off into other, related genera now and whatnot.
Mhm.
But that's what we called an amoeba. And then as we started to discover these other things, we're like, oh, but that kind of moves like an amoeba does. And so technically these things are still considered amoebas, or it's why some people prefer the term amoeboid, just let's say an amoeba-like thing. So if you want to be like a purist, you could say, oh, no, it's really, there's amoebas, which is what I learned about in 9th grade. And then there's all these other things that are amoeboids that sort of act like them. But really, it's like they all kind of share this form of locomotion, even though they're not related. And scientists do refer to all these things as amoebas or amoeboids, even though they're not genetically related. So it is very much kind of like that whole fish thing, where it's a convenient term for us to use. Like, all these things all swim in the water and kind of look at this, they're all fish. And you go, yeah, but they're not really closely related. It's like, they're fish. Don't confuse me, So it's just sort of tradition at this point. If scientists had discovered things in different order, we may only have, the term amoeboid locomotion, let's say, and they might have called amoebas, Rachels. And then we, we wouldn't think this was an interesting topic at all and wouldn't be talking about it.
Yeah.
Yeah. Don't want to get those Rachels up the nose when you're swimming. That's real dangerous.
Ooh. I know.
What a weird note to end on. Woo, thanks, everybody. We're going to call it a wrap right there, and we'll see you next time.
Yeah. Thanks, Alicia, for joining us this week. I really appreciate you coming.
Yeah, thanks so much for including me. This was a lot of fun.
Oh, good.
Excellent. Thanks for being here. And thank you to all of you for listening, and we'll see y'all next week.
Bye.
Bye-bye.
Thanks everyone for listening to today's show. Be sure to subscribe. New episodes drop every Wednesday, and we love sharing this strange world with all of our listeners. If you would be so kind as to leave us a 5-star review, that would be great. It lets other lovers of the strange discover the show. You can reach out to us on social media by searching for Strange by Nature Podcast on Twitter, Facebook, and Instagram. You can send us an email as well. Our address is contact@strangebynaturepodcast.com. If you want more information about the show, you can also check out our website, which is strangebynaturepodcast.com. Until next week, get outside, stay curious, and embrace the strange.